Alright, let's talk about negative of a vector. Now, that is a property of vectors. So if we have a vector A over here, if this is vector A, the negative of vector A would essentially be the same vector in the opposite direction. So this would be negative vector A. The negative of vector A, it has to be a vector which adds to vector A to equal to 0. So again, the negative of vector A has to be a vector when added equals to 0. So this negative A vector, if we add it to this vector over here, it should equal to 0. So that is the negative of a vector. That's how we get the negative of a vector. It will always have the same magnitude, but it will be in the opposite direction. Okay. Alright, so we're going to use this negative of a vector concept, which is essentially taking a vector's negative. So if this is positive vector A, the negative of this would be the same vector's magnitude in the opposite direction, right? So this would be negative A, vector A. Now this concept will be used to subtract vectors, because essentially if we have this vector A here and this vector B here, how do we subtract A minus B? So what is the result of vector A minus vector B? What does that equal to? Well, we know it's vector C, but how does that look graphically? Well, the way it works is we take vector A and we add, even though it says subtract, we take vector A and we add the negative of vector B. So essentially, if this is vector B and we're trying to subtract it from vector A, we will need to flip it. Okay, we will need to flip it so it becomes negative B, and then we add it to vector A. So let's flip it so it will actually look like this, right? It will look like this, right? So this is negative vector B. This negative vector B plus vector A will equal to resultant C, right? So let me pick a different color. Let me draw vector A here, and then draw vector B, which is from here to there, or from here to there. And what we have is this resultant. This is negative B. So we have vector A, right? So we have vector A plus negative B is equal to this vector C here. Now that's one way to think about it. So the question was how to subtract this vector A from or how to subtract this vector A minus this vector B. That was the question. So what we did was we took this vector B and we flipped it to make it a negative vector B, and this negative vector B plus vector A, right? Vector A plus negative vector B is essentially a negative, so A minus B gives us C. And A plus B gives us basically vector A plus vector B, which looked like this. And this is our resultant. Another way to think about it is A minus B, right? Vector A minus vector B is equal to vector C, right? And this vector C is essentially what's left between. So A minus B gives us what is left between, which is vector C. That's also another way to think about it. Alright, in this final scene, I just want to talk about multiplying a vector by a scalar quantity. Now, this shouldn't be too difficult to understand. All I'm trying to say is that if we have a vector A, okay, if this is vector A, and we take this vector and multiply it by a scalar quantity, let's say 5, okay, then this vector will essentially be this 5 times vector A. The sign of this scalar quantity will affect the vector over here. So the vector is now 5A. Likewise, if we have this vector B, for example, over here, and we multiply this vector B by, let's say, -1/4 scalar quantity, then this will essentially equal to -1/4 of vector B, and this vector will now look something like this. It will be essentially 1/4 the length of vector B, and it will go the opposite direction because the sign and the scalar quantity affects the vector quantity.